What's up, guys? It's Mr. Brangle, and today we're going to be going over a VIRP chart for a series circuit. So let's dive right in. You will need to draw your circuit on your paper the same way that I have drawn mine. This symbol is for a battery, these are for light bulbs or resistors, and then I've labeled the battery as 9 volts, and each resistor has a different resistance, 1, 3, and 4 ohms here. So with a VIRP chart, it's a way of organizing our work for math problems with circuits. And you can see the first column here is for voltage, this one is for current, this one's for resistance, this one is for power. So we'll kind of talk about it as we go through it here, but we're going to go ahead and fill in the resistance of our resistors. You can put the units of measurement here, or we could put them up at the top, put this, in ohms like that. But just to be very clear, I'll go ahead and put the units of measurement in on each box here. So 3 ohms, and then the last one is 4 ohms. Then what you're going to do is underneath that, we're going to make kind of a squiggly line, and underneath this will be our total values. Okay, so your totals go down here, and we have a total battery voltage of 9 volts. So I'll leave all the totals in red, and then we'll do our calculations in another color here. I'll leave our givens in red, and then we will do our totals in a different color and then calculations in a different color. So starting off here, the first step for any VIRP chart is to go ahead and calculate this box right here. Step 1 is total resistance. Now, total resistance for a series circuit, we are just going to add our resistors together, R1 plus R2 plus R3. And so this is going to give us a series resistance of 1 plus 3 plus 4, which is equal to 8 total ohms of series resistance. So I'm going to put that in there, 8 ohms. And then step 2 is going to be to calculate the total current. And you always follow these first 2 steps for any circuit, total resistance and then total current. And you may calculate total resistance a different way if it's a different circuit, but total resistance nonetheless. So for this here, when we're calculating a total current value, and I'll put a subscript T there, I sub T for total current, we're going to use the total voltage, which would be the battery voltage, and the total series resistance, which we just calculated. And so this is going to be 9 volts divided by the 8 ohms of total resistance that we just got in the last part of the problem. And I've got my calculator here. We're going to be doing this live, so type it in with me. 9 divided by 8 is 1.125. Now, of course, you could round that answer on here. I'm going to go ahead and leave it as 1.125, and then the unit of measurement for current is amps, so we'll put that right there. And I'll put this answer down here. I guess I should box in my answers. 1.125. I do need you to show your work down here. In this area, no matter how simple the calculation is, please show your work. When we get to this next step, it's about current. The next step, we can go ahead and evaluate our rules for current and voltage in a series circuit. And the one that we want to start with is the current, because the rule for current in a series circuit is that it's the same everywhere. And we've already figured out the number that for the current that's going through all these light bulbs. It's 1.125. The total current in the circuit is taking into account the total resistance already. And so each light bulb is experiencing the same current as the total going through each one. So I'm going to put down here current equals same everywhere for a series circuit. Okay, so this is going to be all the same right here, 1.125. You can either fill it in as 1.125, 1.125, or I'm just going to write same up here as a reminder of the rule, and this number 1.125 gets filled in all the way up to the top. Okay, so actually, I should probably be disciplined about this and go ahead and write it in. I'm going to leave this in blue. So 1.125 amps, and we'll just fill that in on each box. Okay, so that means the rule for voltage is the opposite. It adds, and specifically, that means that it's going to add up from the voltage drop from each light bulb will, when added together, will be equal and opposite to the battery voltage according to the loop rule, which states that as we go through one loop of a circuit, you must have voltage drops that add up to be equal and opposite to your battery voltage. Okay, so we actually have to calculate each of the voltage drops using the equation V equals I times R. Okay, and I'm going to write adds right here. So if this was step 3, calculating current being the same everywhere. In fact, I'll put this up here. Step 4 is going to be your calculations here and here. Okay, so the reason why the VIRP chart is nice, it's kind of already set it up for us, right? V is equal to I times R. Well, that's V is equal to I times R. So we're going to go to each row. We're going to do this current times this resistance to get the voltage drop at the 1 ohm resistor. We'll take the total current going through the circuit, multiply it by the 3 ohm resistor to get the voltage drop right here, and then do the same with the fourth. Okay, so this is an actual calculation. I'm going to fill these in green here. I probably should have changed my colors down here, but that's okay. So we'll call these A, B, and C. For A, voltage drop is equal to 1.125 amps times 1 ohm. For B, it's going to be 1.125 amps times 3 ohms. And for C, voltage is equal to 1.125 amps times 4 ohms. Okay, and then we're going to get answers here, and then we just want to double check at the end of this that these all add up to our total voltage of 9 volts. Okay, so 1.125 times 1 is obviously just 1.125. This would be volts. Okay, and this is a volt drop, so I don't mind if you put the negative sign in there, but it's not needed. Times 3 is going to give us a volt drop of 3.375 volts. And then times 4 is going to give us 4.5 volts. Okay, so let's just quickly add these up. And sure enough, these come out to be 9 exactly. So I'm going to move my video screen here for a second. And I'm just going to put if we add these together, this does come out to be 9 volts, which is what it's supposed to do. And we want to check that every single time. Okay. The last thing that we're going to do, we're going to X out this column for the power at each light bulb, but what we're going to do is go ahead and calculate our total power. So this would be step 5 if we're kind of going with our numbers here. And for number 5, power is equal to current times voltage. And of course, if we want the total power, we should use the total current and the total voltage. And so we're going to do 1.125 amps of total current multiplied by 9 volts of total voltage. And I get 10.125 watts would be our answer there. Okay. Okay, and I've gone to 3 decimals on everything in the chart just for the sake of trying to show you accuracy and not rounding anything and how the numbers all come out. But if you round, that's okay. Just be aware if you round a number like the total current, for instance, and then you have to plug that into future equations, that could get you a little bit further away from the true answer. So just keep that in mind, and I try to leave the number in my calculator and don't actually round it there, even if I round it on my paper. But this will conclude our series VIRP chart. Just helps us organize all of our work here. You will be tested over this. This will be the written portion of your exam. You'll have to fill out a VIRP chart for a series circuit, parallel, and a combo circuit. And I will go over those circuits in a separate video. Thanks for sticking with me, and I hope you learned something.